So guys, I just want to say thank you all. Thank you for reach 1,000 subscribers, and to those of you who are new, keep subscribing. Now that I reach 1,000 subs, I'll definitely be posting a lot more. I'll try to up the quality of my videos a bit, and I'll take it a bit more seriously because you guys obviously like the stuff I'm putting out. So in this video, I want to address a topic. Is it that we are at a point where 8-bit microcontrollers are obsolete? Now, this is an important point because when I first started this channel, I really started with microcontrollers, specifically, the PIC microcontroller, the PIC 32, and I've been doing, working with 8-bit devices for a long time. I actually started embedded development with the PIC 16F54, which is a device that has about 25 bytes of RAM and about zero point 0.7 kilobytes of flash. So now in this age of AI, are we finally at a point where 8-bit microcontrollers are obsolete? So here's the thing, right? I was using 8-bit PICs. I moved to 16 and 32. And then I moved away from that ecosystem and moved more towards the ARM devices because ARM devices, they're really powerful. We have the STM32. I swapped on it when we had the F7. We have the 87. We have things like the N6 that really blur any lines between what's a microprocessor and a microcontroller. If you look at the direction of the industry, we see things like, look at how Qualcomm acquired Arduino. We see any movement from 8-bit stuff like AVR and PICs more towards operating system stuff. But here's the reality, right? Um, if you're doing deeply embedded stuff, you're pushing bits around, you're designing a audio amplifier or a battery touch controller or something like that. For me personally, 8-bit devices still have their place. The number one reason for that is peripherals. Now I'm speaking here from the PIC devices standpoint. You look at my favorite PIC, which is the PIC 16F17181719. You have things like configurable logic blocks, complementary waveform generators, you have the mercury control oscillators, you have so much different stuff. You have op-amps and comparators and a lot of really really co-independent peripherals that you're not going to find on any other of the modern devices, right? And then you have the 16F13145, which has something like it's essentially like a mini FPGA in a chip, right? And for a $2 part or $1 part, you have the ability to have some really complex mixed signal processing, which if you're really into electronics, you kind of understand how important it is to have that. However, the reality is, 8-bit is being thrown for a lot of stuff because for a long time it was cost, right? Yes, 32-bit might be more efficient for some stuff, but 8-bit always won in cost. Now with RISC-V, that has changed, and for a long time, um, any project I had to do, I'd find myself reaching for 8-bit device. These days, I would tend to reach for, one of the 10-cent RISC-V parts just to test a sensor or, test some, really simple part of the design and then flesh out as I need to. And 8-bit really needs to look out because, a lot of the peripherals, yes, they are really unique, but you can do a lot of stuff in software these days with the powerful hardware we get in. Now, something I want to talk about is that with these RISC-V devices is that you have to be careful using some of these newer devices, right? Like take the GD32, RISC-V device was really popular and it's no longer on the market, right? That's somewhere that 8-bit really shines. You have these 8-bit devices that have been around for so long. The chip I started with, the 1654, is still around, right? You can literally go and buy this device still. So, those are stuff we need to we need to consider when we choose a device for our design. It's just about the latest or the greatest, but also, the supplier availability and stuff like that. And 8-bit really shines for that, especially like stuff like PICs and AVRs. Of course, 8051s and stuff, like they say they're like spiders. They really never go more than 3 to 5 feet without an 8051 being here. But that's where we are. So in the age of AI, as advanced as stuff is, yes, there is still a place for 8-bit. It really depends on one your skill level and also what you're doing. If you're a hobbyist, you're just doing stuff on the side, you can pick up a Raspberry Pi Pico or ESP32. You can pick up something really powerful for, $3, $4, right? But if you're really doing professional embedded systems engineering, then, sometimes you want tightly knit systems, and a lot of the 8-bit devices provide that, right? And then familiarity, and there's so much aspects, we could spend so long talking about the trade-offs, but generally, 8-bit is here, right? I've been hearing 8-bit has been dying for the longest while, and so I'm a RISC-V advocate, right? I really try to push RISC-V as much as I could for a lot of applications. The peripherals on these 8-bit devices, you really just can't replace them for a 32-bit device. So again, guys, thanks for tuning in. I'd like to hear your thoughts on this because, we've seen a lot of shift in the industry. Everybody now rushing for these, $10, $12 parts, right, that have all the bells and whistles, but it's not always needed, right? And, to really get people into the industry, they have to be faced with, the reality of stuff. Yes, we have really powerful parts, but sometimes it's more than just power. It's about, one for the buck and other stuff, right? So thanks for watching. If you're new here, make sure and subscribe. Thanks for letting me reach 1,000 subs. And that's it. Just make sure and subscribe to my channel. Thanks, guys.